Hello all. Today we are solving LeetCode problem number 3666, minimum operations to equalize binary string. So you were given a binary string s and an integer k. So in one operation you must choose exactly different indices and flip 0 to 1 and each 1 to zeros. So return the minimum number of operations required to make all characters in the string equal to 1. So if it is not possible, return -1. So we will understand this problem by the first example. We are given k is equal to 1. So the flip the k, how many numbers we can flip, is equal to 1, and we are given the string as 110. So there is only 10, so we need to convert 110 into all ones. So we can use 1 k times operation, which has one flip. We can convert the 0 into 1, and it is now all the values is being flipped into 1, and the minimum operation required is 1. So that is the output which we are returning as the answer. So this problem is a math solution which we are going to follow, and it is due to that reason, and coming up with the solution, with the answer for the solution, is very hard. So it is due to that reason this problem is a hard problem. So let us understand this problem. Let us move step by step. So to make a character into 1, so 0 requires odd number of flips actually. So if we are having 0, to convert this into 1 we need 1 flip, and if you are using 2 flip, this will become 0, right? So 0 to 1, 1 flip, and 1 to 0, it becomes 0 again, and if you are using the third flip it becomes 1. So it is due to that reason. For 0 it is odd times, and for 1 it is even time. So 1, if we flip, it becomes 0, which is first flip, and the second flip, which is the even one, it becomes 1 again. So this is the observation which we have to make first, and we will start from left to right. So based on the index we decide the number of operations. So at index I, if the I index position is 1, we will use 1 into k operations totally. So if it is 2, the second index is second index, we use 2 times k operations, right? So based on that we can say k is equal to 1. So at index position 1 we use 1 into k operations, which is 1 into 1 operation, right? So similarly this is the observation we are coming up with. So I will represent, the index position will always represent the operations, and odd operation means number of zeros I times, and for 1 it is I minus 1 times to flip actually. So similarly for even operations, which is nothing but the index 2 or whatever it is, if the k value is equal to odd, then at index position I is equal to 2, this will be even operation, right? So in that case for 0 it takes I minus 1 times, and for 1 it takes I times. So these are all the observation which we are coming up with based on these explanations. So we are using 2 times basically. So 2 flip, we are converting, like we are flipping 0 to 0 again, and 1 to 1 again, and in 3 flip the 0 is being converted to 1 again, and 1 is being converted to this is even times, right? So 1 again. So the odd times and even times, so which we are, based on this explanation we are coming up with these two observations. This is first observation and this is second observation. So these are based on the odd operation and even operation. In terms of odd operation, 0 takes I times. I represents that odd operations. So for example, we are at index 1 and the k value is equal to 3, which is odd operations now. So it is due to odd operations. For 0 to become convert into 1, it takes 3 times or 3 flips, which is odd operations. So I is what exactly it represents, right? So uh, similarly for even as well, we are coming up with this observation. This will help us to come to a conclusion that based on the that particular operation, the conversion is possible. So just hold on to it. Now we will move to the other operations, other observations. So the flips, total number of flips will be equal to operations, the number of operations, which is the number of I multiplied with k. So sorry about here, because I represents the index position alone, not exactly operations. Not exactly flips. It represents the operations but not the flip, total flip. So total flip is operations times k, so which is decided based on the index. So for flip zeros, we need even to work. Flip minus number of zeros is the condition for which that particular flips will work in order to convert into all ones. So this is an important observation which we have to mind it, because the number of flip, which is operations times k minus number of zeros, if it is even, which means using these operations we could convert the zeros to ones, which is all ones. So and next one is the number of the flips which ranges, because we can say that the flip ranges from 0 to n times, right? Within the length of s range. So to find that the total number of flip, it ranges from 0 greater than or equal to 0, and it should be less than or equal to maximum odd flip for 1 or 0 and maximum even flip for 1 or 0, which is nothing but this. So for odd, the you find the 0 times and you find the even times, right? So if you are at index position 1, you find zeros and 1. This is I times, which is 1 time, and this is 1 minus 1, 0 times, right? So using this one, you decide the maximum odd flip and maximum even flip, right? So based on this condition, you decide the range, and you repeat this till length of length of a string times. So this is the observation we are coming up with, and now I will explain the algorithm, actually how we are proceeding to solve this particular problem. So we have few important observation, which is one and this one, these two observation, and now I will explain the step by step concept. So first one, we have to count the number of ones and zeros from original string. Yes, right. And if zeros equal to 0, then there is no string required to be changed, and you can now return 0 operation, right? Else you start from index 1, because index 0 is no use. So index 1 will cost us the operation. I is the operation, right? So you start from 1 till length of s, and now flip will be equal to the index I multiplied by k, right? So if flip, right, if flip is flip minus 0, which is this particular condition which we said here, right? If it is even, um, we proceed. If it is odd, we move to the next iteration, right? We proceed, else flip minus 0 is odd, move to next. Right, so now expanding this, we will get into the actual problem. So now we have to check the index is odd or even. So index odd, so and index is even. So if index is odd, then you have to you will have uh, a different range which will start from 0 to, here it will be 0 times zeros will be I time, and ones will be I minus 1 time for odd as per the first equation, right? If it is odd operation, so based on that you will have zeros as I times and ones as I minus 1 times. And if it is even, you will have the range from 0 to here 0 will be I minus 1 times and ones will be I times. So you add up this, you will decide the range. And now if this is possible, if it is within the range, if this is true, you return I. So I here decides the number of operations which will be done in order to convert all the zeros into 1. So we continue this for a while and we reach till last the element which is length of s, and still we didn't return any index. Then in that case we return -1. So this takes, we start from 1 till length of x, length of s. So this takes time complexity of big O of n times and space complexity as big O of 1 times. So let me show a dry run for a better understanding so that we can go ahead and come up come up with the code and solve the problem. So we are given the string 0101 and k is equal to 3. So we start by counting zeros. So zeros is equal to 2 and ones is equal to 2, and we will have the index I, and we will calculate flip. Flip will be decided based on the iterations only and the main condition. So we start with the index 1 here. So when I is equal to 1, we have we have to calculate the flip, the operations, which is nothing but 1 multiplied by 3, because k is equal to 3. So the flip is 3, and then flip, number of flip, the condition, basically the condition is equal to number of flip minus number of zeros. So which is 3 minus 2 is equal to 1, which is odd. So you continue to the next iteration, which is I is moved to 2 and flip is updated to 6, and now 6 minus 2 is equal to 4. So it is even, and now you get into the next condition actually. So if it is 4, then there is a possibility. So now you have to check if it is in between since sorry, I'm sorry, I have just confused here. So now it is 4. So now you have to and I is equal to 2. So you have to condition if I is even, I is odd. So I is even, so you move into this condition, which is nothing but this 0 I minus 1 times, and I is equal to I mean 1 is equal to I times. So you will have you have to check if the given flip, which is lying between 0 to 1, the flip is 6, which lies between, you have to calculate I times 1 here, right? So which is nothing but zeros multiplied by I minus 1 and 1 multiplied by I. So you have I as 2, so 0 less than or 6 less than or equal to 0 is 2 times I minus 1 is 1 plus 1 is 2 multiplied by 2. So you have 2 plus 4, which is equal to 6. So 6 less than or equal to 6. So this condition is satisfied, hence you can return 2. So 2 is the answer. We can cross check again, because when we convert, we can convert to 3 flips basically. So this becomes 0 1 0 1 becomes 1 0 0 0 for first flip, and second it becomes 1 1 1 all 1, yeah, in the second flip. So 2 times is required. So with this observation, let us go ahead and code this up. So we start with counting the zeros, is equal to yes dot count, and ones is dot count, right? And if zeros is equal to 0, then return 0, right? And for I in range, we start from 1 till length of yes plus 1 right. Now we have to calculate flips is equal to I star multiplied by k, and then now you will check the condition, that is if flips minus zeros should be even, right? So modulo of 2 is equal to if it is not equal to 0, we move to the next iteration using continue, right? And if yes, we proceed next, which is if I is modulo which is equal to uh, odd 1. So in this case, we check the condition if flips is greater than or equal to zeros and flip sorry, this should be flips, and flips less than or equal to the condition zeros multiplied by I, then plus ones multiplied by I minus 1. So if this is true, I guess yes, ones multiplied by multiplied by I minus 1. So if it is true, return I, and else if flip is greater than or equal to 0, and flips is less than or equal to here it should be again 0 0 zeros multiplied by I minus 1 and added with ones multiplied by I, right? So if it is true, return I here, and if not, return -1. So let us run it. And submit it, and there you go. Thank you.